everyone. In this video, we are going to discuss the solution for selection sort. So, in this question, we have been given a list of integers and we need to sort this list of integers using selection sort algorithm. So, let's see our selection sort algorithm. So, selection sort algorithm is very similar to bubble sort algorithm. Alright. In bubble sort algorithm, we were running our outer loop for -1 number of times. So, same will go here. Our outer loop will run for one number of times, meaning 4 times. So for my first loop, my list will look like this. Okay, my I will sit here, and in selection sort, we need to find the minimum element in the unsorted elements. Okay, so when I'm running my loop for first time, for my first iteration, I will have completely unsorted list. So I need to find my minimum from all these elements. So let's say my minimum will sit here. Let me represent it by M. This is my inner loop. Now what my inner loop is going to do is, my inner loop is going to find the minimum element among the unsorted elements. Okay. So first let's find the minimum element, then I'm going to tell you what I'm going to do with this minimum element. Now let's suppose that my first element is my minimum element, although I know that it is not possible always. So let's see. I will start my inner loop from this j. Check if my jth element is smaller than my minimum element. Now I'm going to check 9 is smaller than minimum. No. Now what happens when my jth element is smaller than my minimum element? I'm going to just say that this is now my jth element has become minimum element. Okay. So for 1.2 be here and minimum will also be here, 9 and 7. J will shift to 7. Now 7 is jth element, 7 is going to check with minimum element 5. Is 7 smaller than? No, 7 is not smaller than 5. So my loop will run as it is, not updating my minimum. 5, 7, 1, 8. Now this is my minimum, this is my I, and here is my J. Now J is checked with minimum. Is 1 is smaller than 5? Yes, 5 is smaller than 1 is smaller than 5. So my minimum will shift from here to here. Now my minimum has become 1. Now for 1.4th iteration, I will be here, 9, 7, 1, 8. Minimum is here. J has reached my last element, which is 8. Okay, now J is going to check with minimum element 1. Is 8 smaller than 1? No, 8 is not smaller than 1. So minimum won't be updated, and what we have is 5, 9, 7, 1, 8. I was here and minimum is at 1. Now what we are going to do is, we are going to swap the ith element with the minimum element. So this will happen. 1, 9, 7, 5 and 8. Okay. Let's shift this. Alright. Now for second equation. Now we have 1, 9, 7, 5, 8. Now first element is already sorted and these 4 elements are still unsorted. So my inner loop will run from these four integers. My I will be here, minimum will also sit here, my j will sit here. Okay, so for 2.1 loop, j is going to check with minimum. Is 7 smaller than 9? Yes, 7 is smaller than 9. So my minimum will shift from 9 to 7. Okay, now 1 is already sorted. 7, 8. I is here, minimum is at here, j is at here. Now j is checking with minimum. Is 5 smaller than 7? Yes, 5 is smaller than 7. My minimum will shift from 7 to my 5. Okay, now for 2.3, 1 is already sorted. 9, 7, 5, 8. This is my I, this is my minimum. Now this here is my j. Now 8 is going to check with 5. Is 8 smaller than 5? No, so nothing will happen. Now 1, which is sorted. 9, 7, 5, 8. I is sitting at 9, minimum is at 5. So what we are going to do, we are going to swap element with minimum element. So here comes 5 and here comes 9. Okay, so let's shift this. Now for third iteration, we have 1, 5, 9, 7. Oh, not 7, it's 8. 1 and 5 are sorted. We have to find minimum from unsorted part. So this is my unsorted part. So I'm going to run my loop for these three elements. This is my 3.1 iteration. 3.1 iteration. My I is at 7. Minimum is also at 7. And j will sit at 9. 9 is smaller than 7. No, 9 is not smaller than 7. So nothing will happen. 3.2. 1, 5 is sorted. 7, 9, 8. I is at 7. Minimum is at 7. J is at 8. 8 smaller than 7. No, 8 is not smaller than 7. So nothing will happen. Now we have 1, 5, 7, 9, 8. Now you can see clearly that my I and M are at same position. So if I swap it or not swap it, the meaning is same. Okay, so let's say we have already swapped it. So I and M minimum are swapped and we got this. Now 1, 5, 7 are sorted. Let's shift this. Now for our last iteration. 1, 5, 7, 9, 8. These elements are sorted. 9 and 8 are still unsorted. Now I is at this position. Minimum is also at this position. J is at this position. Okay. Now, is 8 smaller than 9? Yes, 8 is smaller than 9. My minimum will shift. Now it has become my new minimum. Now 1, 5, 7, 9, 8. I was at 9. Minimum is at this position, 8 position. So what we are going to do, we are going to swap minimum with I. And here it is. Now we have 1, 5, 7, 8, 9. Now we know we have already sorted 1, 5 and 7. 1, 5, 7 and 8. Only 9 is unsorted, but 9 is the only element remaining, which means we have sorted n minus 1 elements from our n elements. If I say that I have already sorted n minus 1 element among the n element, then it means that my last element is already sorted. Okay, you can see here 1, 5, 7, 8, 9. 1, 5, 7, 8. Clearly 1, 5, 7, 8, 9 is the sorted order. Now you can see all the iterations once. Okay, my outer loop was running from 0, 0 till n minus 1, not 0, 1 till n minus 1. Okay, 1, 2, 3, 4 was till 0 to n minus 2. Okay, and my inner loop was running first 4 times, then 3 times, then 2 times, then 1 time. This pattern is very similar to my bubble sort. Our sort time complexity for bubble sort was O of n square, and same is the case there. We are using two loops which are running n times, so our time complexity here is also O of n square, and you can see clearly that we are swapping in the same list. We are not creating another list or using any other variable for storing entire array. We were using only constant space, which was to find the minimum. You can see that we were using minimum variable, which was nothing but constant variable. So that's why we are using constant space. So a space complexity for this algorithm will be O of 1, meaning constant space. So let's now code this and see. Okay, so here it is, selection sort. So we were running our loop for I in range from 0 till length of minus 1. Okay. So you already know that range functions run my loop for length of array of length of array minus 1. Okay, I am now doing minus 1, so it's going to run my loop for n minus 1 number of time. Okay, now minimum, starting my minimum from I for now j in range. You can see while I was starting my loop, I was starting my loop from I plus 1, j plus 1. My j loop or the inner loop was starting from I plus 1. So that's why I'm going to write starting element as I plus 1. I plus 1. Okay, and it will remain till length of okay, f is smaller. Okay, you can see that we have already functions called is smaller and swap function. So is smaller, we need to pass is list arr if my jth element is smaller than my minimum. If my jth element is smaller than minimum, then what I'm going to do is swap, not swap. I have to update my minimum. Minimum equals j. And when my inner loop was ended, then okay, in array or the list. Okay, what I was doing was swap I with minimum. Let's run it. Alright, so it's been accepted for a sample test case. Let's run all test cases. Okay, we got 10 out of 10, which means that our selection sort algorithm is working as it should. Now you must be wondering that why we have used these two functions, the smaller and swap function. Okay, so same case here, like it was in our previous question. For checking if we have made correct algorithm for swapping or not swapping, for selection sort and bubble sort, we have printed some lines here. Okay, for comparison and swapping, so that we our online judge will know that if you have made a selection sort algorithm rather than using sort functions or maybe used another type of sorting. Okay, so that's why we are using these functions, so that our test cases result of test cases match. Okay, so that's all for this video. If you understand everything, then it's well and good. If you are having any trouble in understanding this sorting algorithm, then I will suggest to watch this video again and see its diagram carefully, because this sorting is very easy and you will be able to understand it after you diagram yourself. Okay, so take a small example of unsorted integers and just try to use this selection sort algorithm as a diagram for sorting the unsorted integers that you have taken. Okay, so that's all for this video. See you in the next one.